going to see the different aspect of hash collision and different methods to solve the hash collision. So in the previous video, I have given an introduction to what hash collision means. So as a quick revision, uh, a hash collision happens when two different key gives the same index as a result of the hash function. So in this particular example, hash function is h of k is k modulo 10, and if you pass 122 and 922, you will get the index as 2. So you will be mapping 122 as well as 920 to the same location, so that makes a collision there. Now we are going to see what are different methods by which we can resolve the problem of hash collision. So the topic is hash collision resolving techniques. Okay, so there are two different methods to solve the hash collision uh, issue, or there are two different resolving methods. The first one is open hashing, or it is also called separate chaining, and the second one is closed hashing. It is also called as or known as linear probing or open addressing. So first we will see what is open hashing or separate chaining. So I have given four numbers here, and imagine that the hash function I'm using is h of k equal to k modulo m, or in this case I have m is equal to 10 or 10 different locations, so it will be k modulo 10. Now first I need to insert the number 2, and before that we are using a table, and this table is not storing the numbers directly, and they are storing pointers. So I will uh, talk about what kind of pointers they are storing. So first I need to insert the number 2. So I will pass the number 2 to this hash function. So h of 2, you can see that if you give 2 modulo 10, the result is 2. So I need to insert the number 2. So for inserting the number 2, I'm not inserting the number 2 to the position 2 directly. What I will do is I will create a node just like we created for a linked list with a value 2. Then I will store the pointer to the first node. So this is 2, so I need to store a pointer to the head. So if I create a pointer to the head, and if I insert a node here, so let's say I'm creating a node with value 2, okay, then I will be storing the pointer or the address of that node into this position. So actually this location actually stores the address of the node 2, and this will be connected to null. Okay, so actually we are not storing the number directly, we are creating a linked list which can be used to store the number, and we will be storing the head address of the head of the linked list at this position. That's why I said that these elements should be pointers, and if it is blank, I will be storing it with null value. And if I pass 14, 14 goes to the address, the location 4. So I will create a linked list there. So this null will be replaced with the address of the node having the value 14. So this will be pointing to the node with value 14, and this will be null. Then I need to store 82. So when you pass 82 to the hash function, again you will get the index as 2, but that index is already occupied by this 2, not the 2, but the address of 2. So what we can do is we can create a new node with the value 82, then we can store the number 82 as the next element of this linked list. So there are two options here. I can store 82 after the value 2, I can store the value before the value 2. So we will go for appending before, or we will be inserting at the head of the linked list. The reason is inserting at the head is much more faster than inserting at the end, because if you want to insert at the end of a single linked list, you have to traverse all the way up to the last element of the linked list. So that will make the process more time consuming. So if you are inserting at the head, it can be done with a constant time. So what I will do is I will create a new node, then I will insert it as the first node of my linked list. So I'm taking off this 2, then I'm inserting, so this 2 is a node, and I'm inserting the number 82 here, then that will be connected as the head of this linked list. Then I have the value 71. If you pass 71 to this function, you will get the index as 1. So I have to store that value in the first index. So that is the first element that we are going to store into the location 1. So I will be having a value with the value 1. Okay, then that will be stored in the first index, and this is the first node in the linked list. Then I have to insert the numbers in 93. 93 will go to this position. So I'm creating a new node. So I will insert 93 here. Next I have 47. So 47 should go to 7th position. So I will delete this one. Okay. Then I will create a new node with the value 47. Then I will store the address at this position. Then this will be null. Next I have to store the value 92. So you can see that 92 we will get the index as 2. So the index 2 is already occupied. So we will insert this 92 at the head of the linked list starting from this point. So I will move the other two keys to the right. Okay, then I will insert the new node here with the value 92. Next I have to insert the number 111. So if you pass 111 to this function, you will get 1 as the index. So that is the second value that we are going to insert. So I will take this one, then I will move it to the right, then I will insert the new element as the head of this linked list. So we have the value 1 1 1. Okay, so in this case, if you want to insert a number, this is a procedure, and if you want to search for a number, suppose that you are going to search for a number 82, then we will pass this 80 to the hash function. Hash function will give me the index as 2. So you will give that index into the you will looking at the linked list starting at the index the index stored in the starting at a pointer stored in the index 2. So we'll be just searching only the list, so you don't need to search any of these list. So one thing here is we are not sure that whether it will take only constant time, because it depends on the length of the linked list where I have stored the element that you are searching for. And if you want to delete, will be the same procedure. You will be first finding the index of the linked list using the hash function. Then you will perform the normal linked list deletion procedure only in that particular linked list. So this is the first method, which is called the open hashing or separate chaining. So I think this term will be more meaningful now. We are using separate chain or separate linked list with which gives for values which gives the same index. Okay, so that is all about open hashing. Now next we have to see what is closed hashing or linear probing or open addressing. So that is our next topic. So for closed hashing or linear probing or open addressing, we will simply modify the hash function in this form, that is hi of k equal to h of k plus f of I modulo m. So as I told before, m is the size of the array or the hash table, uh, and f of I is a new function that we have introduced now. Then h of k is actually the hash function that we are using. So if h of k is k, okay, then if f of I is I, then I will talk about the insertion procedure now. So whenever we are finding the hash function or for a specific key for the first time, we'll be using the value 0. In other words, I is the number of iterations that we are using to find a location for a specific number. So I think when I talk about an example, then it will be clear. So here I am using f of I equal to I. So whatever value you pass for I, that will be the value of f of I. Then whatever value you pass for k, that will be the value of h of k. So that is f of I equal to I means, and h of k equal to k means. So if I need to insert the number 2, if you are finding the index for the first time, you will be giving the value of h of 0 equal to 0. Then you are passing the value you need to insert, that is equal to h of 2 plus 0, the 0 because you got the value 0 here, and f of I is I. So h of 2 is 2 plus 2 and 0 modulo 10. So this will be giving you the value 2. So this number 2 should go to the value index 2. So we are inserting the value 2 at index 2. Now we have to insert the number 14. So what we will do, we will again pass the function, pass the value to, we will again pass the value 2 to this function. So you can see that I'm passing 14. Okay, I am passing 14 to this position. So this is 14. So this will be h of 14 plus 0 again, because we are finding a space for 14 for the first time. So h of 14 h of 14 plus 0 modulo 10. So this will be 14 plus 0 modulo 10, that will be 4. So we'll be inserting 14 to the location 4. Next we have to insert the number 82. So if you start doing the same procedure, now if you want to insert the number 82, I will be writing 82 here. So this will be h of 82 plus 0 mod percentage 10. So this will be 82 modulo 10 equal to 2. But you look at the location 2, what happens? Because this position is again already occupied, so we are not able to insert to this location. So what we will do, we will find h1 of 82. That is, we are trying it for the second time. So you will have h of 82 plus 1 modulo 10 modulo 10. So this will be 82 plus 1 modulo 10, or 83 modulo 10, or equal to 3. So we will just check whether 3 is free. So we will insert that number 82 at this location 3. So we will be using this location. Next I will have to insert the number 71. So if you follow the procedure, then I will get the index as 1. So this index 1 is not occupied, so I'll be inserting to the location 1, sorry, 71 to the location 1. Next you have 93. Okay, so you have 93, so you will be first finding the index for 93. So I'll rewrite it. So you'll be first finding h of 93 for the first time. So this will be 93 plus 0 modulo 10. So this will be 3. So you look at 3. 3 is already occupied. Then you will find the value for h of 1. So if you find the value of h1 of a 93, we'll be writing 1 here. So you will get the number 4. 4 is also occupied. Then you will go for h of 2. So h2 of 93, 93 plus 2, 95. Modulo 10 is 5. 5 is vacant. So I will insert the number 93 here. Okay. Next is 47. So I will give the number value 47 here. 47 is already free, so I will insert the value 47 at this point. Again I am getting 92, so 92 will give us the index 2, so I will look at this location that is filled, then I will look at the next location that is also filled, I will look at the next one that is also filled, next one that is filled, then the next one that is not filled, so I will insert 92 here. Then I have the number 111, so the first value we will be getting will be 1, so that is not that is filled. Then we will go for the next one that is filled, the next one is filled, the next one is filled, and we will linearly go through each location one by one until we find a free space. So we'll get a position here 111, so we'll be inserting the number 111 at this location. So this is called the linear probing, that is we are probing each location one by one if a specific location is already filled. Okay. So this is also called closed hashing because all the numbers are confined inside the same array. We are not going for taking any address space outside this particular array, unlike the previous case of open hashing or separate chaining. Okay, I hope this is uh, okay to understand, and thank you.